Hello everyone and welcome back. So today we are going to discuss about graphical view in SAP Datasphere. So what are the features of graphical view editor in SAP Datasphere? So you we can create views on top of remote, replicated or local tables. We can define measures and attributes in analytical datasets. We can create parent child or level based hierarchies in dimension views. It also supports multi language text fields. We can define unions, joins, aggregations. We can rename or remove columns as per our needs. We can add calculations, currency conversions, and filters. We can define exposure for consumptions and share with other spaces. Apply data access controls, input parameter, view persistency, and we can also view the data at each node. So these all options will be available once we will log into SAP Datasphere and we will navigate to graphical view editor. So, in terms of hierarchies, we can add a hierarchy to the dimension to support drill down and drill up in BI client. So, once we will define the hierarchy, it will provide us a flexibility when we will be designing a report, maybe in SAP Analytics Cloud. It will allow us to drill up and drill down based on the type of hierarchy we define. So it supports these three hierarchy types, which is like parent child hierarchy and level based hierarchy. So these two hierarchies will be defined or configured in SAP Datasphere itself, and then we have an external hierarchy which will be extracted from external system. Then we have joins and unions options available. So use joins or union operators to combine data from multiple sources. Several type of SQL joins are available, and those are cross join, full join, inner join is the default join. Then we have left join and we have the right join. Union properties available are union all or union. Set properties and mapping specifics to fit your needs. So these are the properties of joins and unions. Those will be available. And in terms of functions or the name of the buttons that are available in graphical view editor are the filter button. Then we have rename or exclude column button. Then we have calculated column button, aggregation, join suggestion, data viewer, and impact and lineage analysis. So these options will appear in the screen once we will go into the editor. And it's time to move to the demo session. So in terms of description, it was a quick one because we already know that what is the purpose of creating a view. It is basically to represent a data from multiple tables in a way that it can represent a specific business insight. So that's the whole purpose of joining two or more tables. So we are in the data builder uh, panel, and here we will click on new graphical view to create a new graphical view. I will give a quick walk through for all the options available in the graphical view. So in graphical view editor, basically we have two options to get the view and the tables as our source. So you can create a view using other views and tables. So either you can get the views and tables from your repository, or you can get the tables, or you can replicate the tables from the sources that you have. Sources is basically the connections that you have with your SAP Datasphere. So By using this, you can easily replicate any of the tables from the underlying connection. But for this demonstration purpose, we will use a repository. So here we will see how we can join the sales order and sales order item table. So let's suppose sales order is one of our table. So once you drag, it automatically creates one view, replicating all the required columns. Now what we need is basically sales order item. So we can drag this sales order item and drop on the other table. There you will get the option to either you, if you want to replace it, you can replace it. If you want to do the union, you can do that. If you want to do the join, then you can select the join. By default, you can see join is selected. Just drop this table and a inner join is created. You can click on the inner join and then check the details of the join. So here you can see, based on the sales order ID, the join has been created. It's a inner join. Okay, so that's very easy. You can select your cardinality based on how both of the tables are related to each other, whether like one record in sales order table will have exactly one record in sales order item table as well, or whether one record in this table, so exactly one, it will have many records, can have many records in sales order item table. So that is how you can define the cardinality. Okay, so because this is item level, it will have more records, so that is why it is many I have selected in this case. So this is one of the function how you can do the join. You can change the join type as well, like cross join, full join, inner join, left join, or right join, based on your needs. And then you have, let me maximize it. So this is the join window. So here you can see the mapped ones only, unmapped ones, and all. If the join by default, by system default, is not correct, you can click on it, delete it, and then drag and drop your required join. Okay, so this is it for this one. Now the next option is, let's suppose once you are done with the join, you don't want all the fields. So this is the projection. Okay, if you don't want all the fields, so out of these two joins, 13 and 13 and 17, there are 24 uh, total fields coming out of here, because few are common fields between both the tables. So view is getting overall 24 fields. But if you don't need these all 24 fields, you want only few of the fields, then what you can do, you can use this projection and you can go to the details, and then you can hide some of them. Like click on this and then you can exclude this column, so this will be get excluded. If you don't want item status, so you can just simply exclude it. If you want to change the name of any of the column, then what you can do, sales, like if you want to change the name, business name, sorry, sales, so based on your need you can change the name. So it is not changing the name of the field in the table, but in the view. So in the view you will be able to have this, and then you can use this view for your analytical purposes. So accordingly, because table is meant for business purposes, and each table has its own perspective whenever it was designed or developed. But when you combine multiple tables for your specific analytical needs, you might need a naming convention for your analytical purpose for easy understanding. So this is really useful to rename your columns. Now next one is the function option is basically a calculated columns you can create out of it. So let's suppose after joining these two tables, you also want to calculate something. Okay, so you have the net amount, you have the tax amount, and let's suppose by clicking over here you can do two actions. One is calculated column you can create, and you can also do currency conversion. So all the amounts, let's suppose in USD, you can do the currency conversion using this option. So let's create a calculated column and let's name it as percentage, and let's give an data type as decimal float, and here we will give an expression as tax amount divided by amount, and we will multiply it with 100 to get the percentage. We did the formula, so formula is okay, no error, validation method successful. Here you can get all the available functions available for this um calculated columns. So you can, it is similar to, if you are a BW consultant, it is more or less similar to a field routine or calculated. So in the field routine, you have an option to use some predefined calculations. So this is somewhere similar. So you can create days between the two dates. You can get the date, a day of the year, day of the month, using the date columns as well. So lot many functions are available. You can, if you are interested to know more, you can just go through it one by one, and it also have a description of that function. Okay, I'll go back. So this is the need of the function. One important feature is aggregation. So let's suppose in order items I also have the item line number. Okay, but let's suppose I don't need the line number in, because I am doing a join. I don't need the line number in my final table. So what I will do, I will click on this order item and I will click on aggregation. Okay, so it will create an aggregation like this, and what I will also do is I will create a projection over here. Let me hide it, otherwise it will keep on loading. It's loaded. Okay, so let's search for the item. So this is the item. Okay, so I don't need the item, so I will exclude it. So in my result I don't need the item, because this is my key, which is the sales order ID, which is common in both the tables. So I excluded the item. But because I excluded one of the key, the granularity of this table will change. And if the granularity of this table will change, then I need to aggregate it. So I will go to the aggregation, and then by default you can see it has taken as sum. Okay, but in case instead of sum you want to have any like minimum, maximum, you can click on it and you can change it as minimum, maximum, count, or sum. These are the total 5 options that is available. If you want to have a count of order IDs or count of products, not for the products you will get, but only the integer ones, whichever is the integer. Okay, or the dates. So for the date one as well. So this is a delivery date, but while creating the table we have assigned it as a number. That is why it is appearing over here, otherwise it will not appear. So the summation will only appear for number or floats, which is integer or float. Okay, so in this case we have total four uh, measures, which is gross amount, net amount, tax amount, and quantity, which has an option for summation. We can change it as per our need if needed. Okay, in this case we are not going to change anything. I just wanted to showcase the use of this summation option. And another thing is, like, if let's suppose your sales order table has 10 years of data and your sales order item table has only 3 years of the data. Okay, so basically you are going to do the analysis on 3 years of the data, which is common in both. So then it is no point in pulling all the 10 years of data for sales order. So in that case you can use the filter option. Okay, let's see if we have any system date kind of thing over here. I'm just checking. So here we have the current date function. So create date equal to create date less than equal to this, and create date greater than equal to current date minus, let's suppose. So we need 3 years, right? So 3 years will be 365 into 3, which will be 1095. Okay, created expression is not valid. We need to check how it takes the variable. Not correct. Yes, so this is fine. We can see we have validated. I'm not, as of now I'm not sure if the formula is correct, but what I am trying to do here is I am trying to put a filter on create date, so that create date is less than or equal to current date, which is today's date, and is greater than equal to current date minus 1065, that is last 3 years. Okay, so this is how we can put a filter. So once we click on a table, we discussed about the projections. So projections are used to rename the columns or exclude the columns. Calculated columns, we have discussed how we can create. It is basically used to create a calculated column using the expressions, and also to do the currency conversion. Then we discussed about the aggregation. in case the granularity changes, or in case we want to um, have a count or minimum maximum kind of an aggregation, then we can use it. Then this is the join suggestions which system suggests. Then we can view the data um, at any point in our graphical view editor. So I have already hidden it. Now let me maximize it. Okay, here you have an option to delete if you want to delete anything. I will click on the view, and then I can click on the data preview. Date is invalid for subtraction operator. Okay, so our filter is not working. It has shown as valid, but it's not the case actually. So let's use the formula that is given over here, which is add days. So we have lot of formula, but I haven't gone through each of them. I'm just checking what all options are available. So let's go to add days. So you can check the syntax. Syntax is add days, then you can give the date and the number of days. Okay, so here what I will do add days, and my day will be current day, and number of days will be minus 1065. Validate. Something is wrong. uh, add days, is it because of the minus sign? Let me check. Still error. So let's try now. Let's check the sales order, and let's see what dates are available. So we can see the create date over here. So what is the create date? So we can see it is already 2018 and we are in 2024. So if I will try to see the data of last 3 years, nothing will appear. So this is the reason uh, nothing is coming up. So what I can do, I can go back to the filter, and I'll increase the number. So I'll increase this number, hide it, go back the data. So the data is appearing now, you can see. So this is pretty easy to create a view using a graphical view editor. So we are done with creating the sales order view. So we have joined our sales order item and sales order table together. So similarly we can join all transaction or the fact table together, and at the end, once we are done with creating the view, we can create the required associations. So here you can see these are the measures that we have, and these are the attributes that we have. If anything is a measure, you can drag and drop like this. Simple. So if this is not an attribute, you can move it from the attribute to measure part. Then once you scroll further down, you have an input parameter option. So you can create an input parameter for your view, where you can put the filter option. Once you will run the view, it will ask you for the value of that input parameter. Then you have data persistence, then you have associations. So here you can create an association. So let's suppose your sales order has a partner ID. So you can create association with uh, business partner. Let's click OK, and the association is created with a partner ID as the key. Let's go back. So this is very simple. You have joined two fact tables and you have associated the dimension table so that you can drill down to the dimension table while you will be running your analytical query. There is also an option that if you want to consume this view in any other system, either SAP or non-SAP, then you can turn it on so that this will be exposed for consumption. You can also create an analytical model out of it. So what we will do, we will first save this view. So this is our analytical view where we have our sales order view, and partner ID is associated with the sales order view. We will preview the data first. So in the preview, we can see the data from both the tables. Okay. And here in the partner ID, we can see all the attributes of the partner ID can be added. So let's suppose if you want to see the data by company name, we can just simply add it. So this provides a very useful feature how you can drill down your data. So this because we did association with the business partner, so all the features of the business partner are available. So all the attributes we can use in our data. So this is a tabular format, but once we will be designing a dashboard in SSC, then also this will be really helpful. So this is what I wanted to show you, how it appears over here. So let's go back to the data builder, and we will see the final thing that we wanted to discuss in this session, which is the hierarchy. So how we can create a hierarchy. So we will go to new graphical view. So let's suppose we bring the partner ID here. Yeah, and we'll change the view as dimension. Then here we will get the option for hierarchy. So we will click on the hierarchy, and here we will have an option of parent child relationship, level based or external hierarchy. So if you have a label based hierarchy, then you can select like this. So instead of I'm not sure if we have anything available here. So let's say partner role. So partner role is the top level, let's say, and within partner role we have the partner ID. So by this we can create a two level of hierarchy. Similarly, we can create multiple levels of hierarchy, like in case we are dealing with address table, then we have the top node as the region, and within that region we have country, within country we have states, within state we have cities, within cities we have a specific postal code or something. So in that case the level is a lot more, like 6 7 level of hierarchy in that case. So like that you can create a hierarchy. In case of the dimension table, you should have all the related information available. Next one is like how you can do a parent child. So parent child is hierarchy is can be done in case of like an employee. So one employee is manager of one employee, and he also have someone as his manager. So that is an example of parent child hierarchy. So parent child hierarchy is also very important, and here also you can you need a similar kind of information, and then you need to maintain it. So for parent child you need to maintain it. For level based you can just simply select the levels. That's very simple. So let's delete it, and if we go to parent child, here you can see which is the parent, which is the child it is asking. Okay, so here you need to select all. So one parent, another child, one parent, another child, and so on, so that the hierarchy will get created. So for this case, so this is I just wanted to show you how you can create a hierarchy. And once you create a hierarchy, let's suppose you create a level based hierarchy. So first level is role, second level is parent ID. Okay, and let's save it. Let's save. Okay, now if you do analytical query using this view one in your, so you can use this view one in your any of the view, and then in the final analytical model you will be able to use the hierarchy that we have just derived. So now I created an analytical model where I have the sales order view as the view, and I have an association as another view where we have created the um, hierarchy. So this is the view one where we created the hierarchy. Now if I go to the data preview, so in the data preview, once we will scroll down, we can see we have a parent id, partner id, and all the respective fields available in the partner id. So what we will do, so here you can see you have an hierarchy option and you can select the hierarchy. So because we created the hierarchy, this hierarchy option is coming up. Yeah, let's remove this. So this is the hierarchy. So here we can see we have the um, partner role as the top node, and then the next level is the partner id. So this is level based hierarchy, how it works. Similarly, you can use it. So this was it, what I wanted to cover in this session regarding a graphical view editor in SAP Datasphere. If you like the video, to subscribe to the channel. If you want to receive the notification regarding the latest uploads, please press on the bell icon. We will discuss about other aspects or other objects of the data sphere in the next session. Till then, stay tuned. Have a nice day. Bye bye.